Okay, so whenever we write the statement sine of pi over 6 equals 1/2, right? It asks us to write an equivalent form using arc sine. So I like to sort of think about this as like I would for solving equations. For this, so if I want to get rid of sine, I have to do the inverse of sine, right? Much like if I had a log and I wanted to get rid of a log, I'd have to do an exponential because that's the inverse of that function. So when we want to get rid of a sine, we need to do the inverse sine. So, so they're telling us to use arc sine notation here. You can choose which one you prefer. You can do sine inverse notation here, which will cancel out here, and you're doing sine inverse on this side as well. So you should get pi over 6 equals sine inverse of 1/2. Or you could write it this way, pi over 6 equals arc sine of 1/2. That's interchangeable notation. It just depends on what they decide to give you. I think AP has leaned towards using the inverse notation here with that -1 more lately, but there's a chance you could see either one, so we'll have them both there. Now, I sometimes like to think of this more of like an equation, but whenever you have arc sine, right here, or inverse sine, either one, let's point an arrow to either one. They're the same thing, just different ways of writing it. When you have this, what it's asking you is asking where does sine, where does sine of x equal 1/2? It's essentially what we were doing for the warm-up, right? If I'm finding inverse sine of 1/2, I'm saying where does sine equal 1/2. Okay? When you're doing inverse sine, your answer should be an angle, right? Which this would be an angle. Pi over 6 would be radians right here. Now, you have to restrict the domains of inverse trig functions because they are repeated. So, like, whenever we find inverse trig, what would happen here if we reflected this over the line y equals x to find the inverse is we would have like we'd have a squiggle that went like this, sort of, right? And then that would not be a function because it would not pass the vertical line test. So what we'll do for sine is we restrict to what are sometimes called principal values. I don't know if he uses that phrase here. But from -pi/2 to pi/2. That section is selected because you don't have any values repeated in that section. And it covers both the negatives and positives there. Okay? For cosine, however, you can't go from -2 to positive, or -pi/2 to positive pi/2, because if you did, it would be this section, and that is going to have some repeated values. It would never cover any of the negatives, right? So, on cosine, your restricted domain is from 0 to pi. And then, does he... I don't guess he tells that earlier. So, for tangent, tangent is sine over cosine, and because of your vertical asymptotes, you're going to go from -pi/2 to pi/2, right? If you think about that graph of tangent, he didn't put it here, but you have vertical asymptotes at -pi/2 and positive pi/2, and then it starts to repeat again after that. So, when we're talking about this, and you may see this, let's write this down because if I use some of my older stuff. Our textbook used to call this principal values. And if you're solving an equation for principal values, you're only using these sections of the unit circle, right? So for sine and tangent, notice those two are the same. Sine and tangent are the same, and you're looking at negative pi over 2 to pi over 2. So first and fourth quadrant, but if you're in the fourth quadrant, you're talking negative values, not like 11 pi over 6. You'd call it negative pi over 6 instead. For cosine, you're looking from 0 to pi. Okay, so let's look at what your questions are going to look like for this. So one thing that you're going to have for this is it's just going to ask you to evaluate the expressions. Inverse cosine of negative pi over 2. Negative square root of 2 over 2. I don't know, I'm backwards today. So what this means is, where does cosine of x equal negative square root of 2 over 2? So we're thinking on our unit circle, we are only looking at the top half of the circle, because for cosine, we already said we just want to go from 0 to pi. And I'm looking for negative square root of 2 over 2. Where is that going to happen on my unit circle? It's going to be over here at 3 pi over 4. Right, because right here you have the coordinates negative root 2 over 2 and positive root 2 over 2. And for cosine, we would be looking at the x coordinates. Right? So our answer for this would be 3 pi over 4. Now, when they're just giving you a inverse cosine function right here, like this, you just have to give the one answer. Because in order for you to do the inverse cosine, that domain is going to be restricted. What we're going to see, where I was adding that 2 pi k, when we get to the end of class today, we're going to be solving equations, and it's going to depend on what they have asked us to do. We might need to say there's more answers to this. But if they're just asking you to evaluate an expression, you're just given that single answer that shows up in the domain for that function. Okay? All right. Mm-hmm.
So, like, we just kind of ignore the negative 1 and put an x for that one?
Yeah, so you could also sort of think about it like this. You got cosine inverse of negative square root of 2 over 2 equals, let's put an x over here, right? If I need to get rid of inverse cosine, I'd use regular cosine, right? Regular cosine. Yeah.
We just got problem, we basically just did that as where does it equal?
Right, you're asking, like, where does it equal?
There's no major changes.
Right. That little negative 1, and you got to remember too, it's not like a negative 1 exponent. It's saying the inverse of cosine. So it's really asking you, like, that negative 1 is, where does cosine equal, is what it's asking you there. So, like, B, is that saying, where does sine x equal negative square root of 3 over 2? Now, for this one, if we're looking at sine, we are going from negative pi over 2 to positive pi over 2. I know it's got to be fourth quadrant if I'm getting a negative answer, right? Where am I going to get a negative square root of 3 over 2? It is, our answer is not 5 pi over 3, but it's the same spot as 5 pi over 3. So 5 pi over 3 is right here, and the coordinates for that are 1/2 negative square root of 3 over 2. So that's definitely the spot that we're looking at. We're looking right here where our y coordinate, which is sine, is negative square root of 3 over 2. However, is 5 pi over 3 between negative pi over 2 and positive pi over 2? If you think decimals on this, if you're thinking decimals, which I mean this is not calculator active, but if you were thinking about the decimals that you would have, where's my if you were thinking about the decimals that you would have, if I do negative pi divided by, oh gosh, what happened there? Negative pi divided by 2, I get negative 1.57, and then if I did positive pi over 2, I'd get positive 1.57. If I type in 5 pi over 3, I get 5.23598. That's too big, right? It's not within that range. So whenever we're looking in the fourth quadrant right here, we want to be thinking about negative angles, like going in this direction right here. So what would 5 pi over 3 be as a negative angle? It's going to be negative pi over 3. Okay. Another way that you can do that, if you're having to do that fourth quadrant, this is only going to happen when your answers are in the fourth quadrant, is if you do 5 pi over 3, if you subtract 2 pi from it, it's like 2 pi over 1. You'd have to get common denominators. 5 pi over 3 minus 6 pi over 3 would give you negative pi over 3. So if you're in that fourth quadrant and you're doing inverse trig, you want to report those answers as negative angles. So you don't want to use the values that are on the unit circle. You want to subtract 2 pi from the values that are on the unit circle. Okay.
That's only for sine, right? Okay, for cosine.
It can also happen for, well, no, actually, no. It will not happen for cosine because what is our domain for our cosine? 0 to pi. So 0 to pi is just the values that are there. So it can also happen, Lucas, for tangent. Because tangent is going to have that same domain as sine. So it's happening right here when you're in that fourth quadrant.
So
on
after
those.
you find like what it is, like pi over 3, even if it was something else, you have to subtract it by 2 pi.
Right. Right. So if you had like 11 pi over 6, you would subtract 2 pi and give you negative pi over 6.
If it's in the upper one.
Right, you don't have to do anything for that because the values there between 0 and pi over 2 are just the values between 0 and pi over 2. You don't have to do anything special there.
I just thought you were like going in 2 pi, like for no reason.
It's a full rotation, so it gives you the same value. What you're really thinking about here, I usually just think of it this way. Like if I've got what is 5 pi over 3 right here, if I think about this far would be positive pi over 3. So if you're going that same direction in the negative, that's negative pi over 3 for that. Sort of think about what it looks like visually as well. All right, now we got inverse tangent equals square root of 3. This is harder because tangent is not on your unit circle, right? How do we find tangent? Sine over cosine. So let's first of all think about it. If we are doing tangent, we are only looking at the first and the third quadrants. We're going from negative pi over 2 up here to pi over 2, right? If I get a positive answer, which quadrant am I in? I'm in the top quadrant because sine divided by cosine, in order for that to be positive, they either got to be both positive or both negative. Both negative be over here in the third quadrant. We don't use it for any of these problems, right? So it's going to be first quadrant. I know the coordinates here are going to be 1/2, square root of 3 over 2, 1/2. Then I've got square root of 2 over 2, square root of 2 over 2. And then I've got up here 1/2 square root of 3 over 2. Or it could be right here at 1, 0 and up here at 0, 1. So it's somewhere in here. But there should only be 2 of those that look possible for you. Which ones look like they might give you square root of 3? There. The ones that have a square root of 3, that looks like a 3 right there, but it's not. So you're looking at either here or here. It's either at pi over 6 or pi over 3. And I, a lot of times, have a hard time remembering which one's which, so I've just got to check. right? So if I do tangent of pi over 6, that would be sine, which is 1/2, over cosine, which is square root of 3 over 2. And dividing fractions is easy as pie. I'm going to flip the second and multiply, and I'm getting the 2's will cancel, and I will get 1 over the square root of 3, which can be written as square root of 3 over 3, but it doesn't equal square root of 3, right? So it is not that one. So are you guys okay if we just go ahead and say it's got to be pi over 3, because those are your only two options, right? If we did that, we'd do square root of 3 over 2 divided by 1/2, which would be square root of 3 over 2 times 2 over 1. 2's would cancel. I would get square root of 3. So pi over 3 would be my answer there. So inverse tangent is going to take a little more thinking because it's not on the unit circle. You can memorize tangent values if you'd like for that to make it a little quicker, but I usually just narrow it down. I knew it had to be one of these two. I checked to see if it's one. If it's not it, it's got to be the other. And you might do that enough that you realize what is going on. All right. The last type of problem that they might give you is this weird problem here. So let's work through this one. It says the angle theta is in standard position. The terminal ray intersects the unit circle at point P, whose coordinates are x, y. The points Q, R, and S are the result of the terminal ray being reflected over the y-axis, the origin, and x-axis, respectively. For each of the following expressions, determine which labeled point intersects the terminal ray of the given angles. So let's think about our coordinates here. What would the coordinate, if P is x, y, what are the coordinates of Q? Negative x, y, right? If we flip that over the y-axis, we're going to have a negative x coordinate here, a positive y coordinate. What will we get for R? Negative x, negative y. What about for S? X, negative y. Okay, so it's saying for each of the following expressions, determine which labeled point intersects the terminal ray of the given angle. So we know P would be like what goes with the original theta angle, right? So we're trying to figure out what point this would go with. So if inverse cosine equals x, which point, we're not going to use P because they told us that's like our starting point, right? The other ones are Q, R, and S. Which point would go with the inverse cosine equals x? It'll be S. Because it's saying, where does cosine, I'll use theta, equal x? Right there. And cosine is your x coordinate, and the only place that equals x is right here at S. All right, so it'd be whatever angle goes with S would be your answer there. What about inverse sine of y? Or, I'm sorry. Actually, hold on. Oh, it's just asking for where we intersect. If it was asking for an angle, we'd have to have like a negative angle right there. But it just asks us what point we're intersecting at. So, it's fine. Inverse sine of negative y. All right, where would that be? Okay, S and R, but if we're restricting to our domain for inverse sine, which one should we use? S. Because really, nothing will be in the third quadrant whenever we're doing these problems there. All right, what about C? Cosine, inverse cosine of negative x. That would be Q. Again, it could be R, but restricted to the domain for cosine, Q is the only one we're going to use. All right, what about D? It's going to be S. Could it be Q if we weren't worried about the domain? It could also be q because that would be negative y, or y over negative x, which would be the same here. But the domain for tangent is the first and fourth quadrant, so we would choose S for that. Okay, does that make sense? All right, we are going to sine of x equals 1/2, inverse sine of 1/2 equals x. Are those two equivalent? They are, because this one basically says where does sine x equal 1/2. That's what happens when we're doing inverse trig, right? So these are equivalent to each other, mostly. The difference is going to be is that inverse sine is going to be restricted to a domain, whereas our original equation may or may not be, depending on how the question is worded. So on the unit circle, if we do this second one right here, we would only give pi over 6 as our answer, right? Pi over 6 would be our answer here. But for the first one, there's more possibilities because sine of 5 pi over 6 also equals 1/2. And then those would continue on and on and on. There'll be multiple answers. So they are pretty much the same. But when we're dealing with trig equations, our domain may not be restricted. To find a general solution of a trig equation, we did this a little bit in the warm-up. Since we know sine of x equals 1/2, whenever x equals pi over 6 and 5 pi over 6, it also, since we know the period is 2 pi, we also know that sine x equals 1/2 whenever x equals pi over 6 plus 2 pi, or 5 pi over 6 plus 2 pi. Or we could keep adding that over and over and over and over again, right? So if we are writing general solutions to a trig equation, then whenever we find, like where sine x equals 1/2, we could do pi over 6 plus 2 pi k, where k is an integer, and 5 pi over 6 plus 2 pi k, where k is an integer, which is what we were doing on the warm-up, right? Same thing if we had cosine equals 1/2. That would happen at pi over 3 and 5 pi over 3. But both of those we could add 2 pi k to it. Tangent's a little different. What's a little different about tangent here? You add pi k. So like if you think about on that unit circle where tangent equals 1, that happens right here at pi over 4 because you've got square root of 2 over 2 and square root of 2 over 2. It would also happen over here at 5 pi. Oh, sorry. It doesn't like it if I write right there, 5 pi over 4. And that point is negative square root of 2 over 2, negative square root of 2 over 2. So it is possible, we did this one on the warm-up. I wrote the answers like this. X equals pi over 4 plus 2 pi k. And x equals 5 pi over 4 plus 2 pi k. But that's not how they're given the answers here. The reason for that is the period of tangent is just pi. So if we just want to look at the first and fourth quadrants here, we can just take those answers and add pi k to them, because pi over 4 plus pi, right? If we added those together, pi would be over 1. And we'd have pi over 4 plus 4 pi over 4, which would give me 5 pi over 4. So by writing it this way, pi over 4 plus pi times k, I'm not duplicating my answers because like pi over 4 plus 2 pi k and 5 pi over 4 plus 2 pi k sort of make it more complicated than it needs to be for tangent. So we'll look at that on tangent whenever we do a few problems here. With sine and cosine, you're pretty much just always going to do plus 2 pi k there. All right, so find all solutions to the equation cosine x equals negative square root of 2 over 2. All right, and so if we're looking at our unit circle, The root 2 over 2's, they happen at the pi over 4's, right? Where does cosine equal negative square root of 2 over 2? Second quadrant, right here. That one's going to be negative square root of 2 over 2 and positive square root of 2 over 2. And over here, that one's going to be negative square root of 2 over 2, positive square root of 2 over 2. No, sorry, both of them negative there. You're looking at your x coordinates there. What is our angle here for? That is 3 pi over 4, but they did not restrict our domain here, so we need to put plus 2 pi times k for that. And then in the third quadrant, what's our value there? 5 pi over 4. But there's actually infinite values that exist there, so we'll do plus 2 pi k there as well. We need to say k is an integer.
So, do you know if it's restricted or not?
If it is just asking you to do inverse trig, like it was on the others, where it was saying like, if it had cosine inverse of negative square root of 2 over 2, like that. If you're using inverse cosine notation, then it's restricted for that. But if it's an equation, like it's saying cosine of something equals this, then, and it doesn't give you any other information, then it's not restricted. You gotta give all the answers. Okay? If I look at example 2, it says find all the solutions where sine x equals negative 1. So we're thinking on our unit circle. Here's 1, 0, 0, 1. Here's our negative 1, 0, and our 0, negative 1. Sine, which coordinate should I be looking at, x or y? Y. Where is it going to happen? 3 pi over 2. So I can say x equals 3 pi over 2. And then it's going to happen over and over and over again at that point. So I could put plus 2 pi k, where k is an integer. Would this be an acceptable answer? Negative pi over 2 plus 2 pi k, where k is an integer. Okay? Why would that be okay? It's backwards, right? Because 3 pi over 2 is like if we go this way, right? That's 3 pi over 2. But if I do pi over 2, or negative pi over 2, it's the same place, but it's just backwards. So it just depends on that. If it's a free response, either one of these are going to be perfectly fine answers. You don't need to put them both. You could just put one. If it's multiple choice, they won't put them both there. It'll just be one of them will be there as the correct answer. So it just depends on how it's given to you for that, whether they use the 3 pi over 2 or the negative pi over 2. We just need to recognize those are the same thing on the unit circle. All right, let's do a tangent problem because it is more difficult in a couple ways. So first of all, it's more difficult because tangent is not just straight up on the unit circle, right? Tangent, we got to kind of figure it out. So we've done this a few times. It's either right here where it's square root of 3 over 2, 1/2, or it's over here where it's 1/2 square root of 3 over 2. Which one was it? We've done this a few times. Which one gives you the 1 over square root of 3? It's that bottom one. It's that pi over 6 right there. Another way we could think about it, 1 divided by square root of 3 is, square root of 3 is bigger than 1. Like, that's a smaller number. If I'm doing 1/2 divided by square root of 3 over 2, that's going to give me something smaller than 1 because the smaller number's on top, bigger number is on bottom. Whereas here, you're doing a bigger number on top, smaller number on bottom. So it's going to give you the positive square root of 3, or just the regular square root of 3 there. So tangent of this x could definitely be pi over 6. It's not going to be able to be any other value for tangent, because if you go down into the fourth quadrant or the second quadrant, either one here, you're going to get negatives. Because tangent repeats over its value, or its period is pi, I don't really need to look in the other quadrants for answers here. I'm just going to put plus pi k. Now, it is going to be true that over here at 7 pi over 6, you're going to have negative square root of 3 over 2 and negative 1/2. And that 7 pi over 6 is also an answer. But what if k equals 1, right? Then pi over 6 plus pi would give you 7 pi over 6. So it's already covered here. So when you're looking at tangent, you really only need to look at 2 quadrants. And then you can just put pi k with it for that. Does that make sense? Okay. We're going to do just a couple more simple ones right here. We'll see if we can get 4 and 5 done. So whenever you are solving trig equations, you want to isolate the trig function. So you got to get the trig function by itself on one side. Then you'll find the angle measures, consider domain restrictions, and write the solutions. So getting the sine function by itself and really, actually, there's going to be some other possibilities, but this is for simple ones anyway. If I've got, what are all the values of theta where 6 sine theta equals 3 square root of 2, right? This is not like the problems I was doing up here because sine's not by itself. So what would I need to do to get sine by itself? I would divide by 6. So I would divide by 6 here, divide by 6 here. Whenever I divide by 6, I can reduce things that are on the outside of the square root, which means that 3 and the 6 can reduce. And I'm going to get square root of 2 over 2. Where does sine equal square root of 2 over 2? Pi over 4. And what can I put with it? Because I don't have any restrictions here. Plus 2 pi k. Where else does sine equal square root of 2 over 2? What? 3 pi over 4 as well, plus 2 pi k, and we need to say that k is an integer. Here. Okay, now 5 is just going to be a little bit different. It's first way, the way question is asked is a little bit different. They love to do this on AP type problems. And notice something that you see here we haven't seen yet. 0 is less than theta, less than 2 pi. They're telling us our answers can only come from the unit circle, right? So do we need the plus 2 pi k on these? We do not, because we are only given answers between 0 and 2 pi. So we're not going to put the plus 2 pi k if we see restrictions on our domain like this. If we don't have restrictions on our domain, we need it, like example 4. But on 5, we're not going to need it. It gives us 2 functions, f of x equals 3 plus 2 cosine x, and g of x equals 2. And it wants to know the points of intersection of the graph. To find where graphs intersect, what do we do algebraically? Set them equal. So we're going to do 3 plus 2 cosine x equals 2. So it essentially could have just given us that equation and asked us to solve, but they like to give us things like this to make sure we know what we're doing. So if I'm trying to solve that for the x, I got to get the cosine by itself first. What would I do first? Subtract that 3. So 2 cosine x would equal -1. What would I do next? Divide by 2. And hopefully when you do this, it's going to give you something that is a unit circle value, and -1/2 is a unit circle value. Where on the unit circle does cosine equal -1/2? 2 pi over 3. Where else? 4 pi over 3. And because this has just restricted us 0 to 2 pi. We're not going to put plus 2 pi k for this. Does that make sense?
Yeah.
Okay. So